All right, guys, so the last part here, I'm not going to sketch this function. I'm not worried about that. You guys can put this thing in Desmos or in your graphing calculator, and you can determine the function. That's pretty straightforward. But the last piece here is asking where the function is concave up and concave down. So the last video, we just discussed inflection point. So we determined that at -6 square roots of 3, we had an inflection point at 0, 0, and that at 6 square roots of 3, we had another inflection point. So we can test for concavity here. That might be the most simple. There's a few different ways, but we will use our theorems and our tests that were provided. So what we would do, first of all, I should probably make sure that we understand what either 6 or negative or positive 6 square roots of 3 equal. So if I put that in my calculator, let's give you an approximation. So if I put 6 square root of 3 in my calculator, that gives me approximately 10.39. So I could put that on my number line to give you an idea of approximately what that value is. So what I could do now is I could pick a number such that is less than negative 10.39, such as negative 11. I could let x equal negative 11, and I can substitute that value into that second derivative. And what was that second derivative? It's probably right in front of my face and I don't see it. Okay, so it is 2x. So 2x in this case is negative 11. And then we have x squared. So I have that negative 11 squared minus 108. And then we are going to divide that by the x squared, so that would be negative 11 squared plus 36 all cubed, I think. Yes. Now, if I simplify that, give me just a second, because I'm pretty sure that I can just put a lot of this right into our calculator. You can put this in Desmos if you want to. So I have that a negative 11 squared minus 108. And then if I multiply that, I lost it, squared. So I have 13 and I have 2 times negative 11 times 13. And in my numerator, that would give me a negative 286. And in my denominator, I'm just going to be honest, I really don't care about the number. I could have just looked at my signs. So in my denominator, I know that I have a negative 11, but when I square that, that's going to be positive, correct? So when I cube a positive number, the outcome is positive. So a negative divided by a positive is negative. And what that means in relation to concavity is that's telling me that at that interval, we are concave down. And we can do the same thing for the interval between 0 and negative 10.39. So I could let x be equal to negative 1. And so that would give me 2 times negative 1 times negative 1 squared minus 108. There's 2 parentheses there. And that would be divided by negative 1 squared plus 36 all cubed. And again, I don't really care about what the actual number is. If I look at that numerator, I know I have that negative 1 squared, but that's just 1. And 1 minus 108, of course, is a negative number. So in my numerator, I have 2 times a negative number times a negative number, so that's going to be positive. And in my denominator, for the very same reason as before, my denominator will always be positive, okay? So that's positive. And so what that means is that is going to be concave up. And we can test with a positive one for the interval between 0 and 6 square roots of 3. So for there, I could let x be equal to 1. And so that gives me 2 times 1 times 1 squared minus 108 divided by 1 squared plus 36 all cubed. Excuse me. And again, I'm not really concerned about the number. I'm just concerned about the sign. So when I look here, I know that 1 minus, oops, that is not a highlighter. Let's fix this. So when I look at that numerator, I know that 1 squared minus 108, that's negative. All right, so I have a negative times a positive times a positive. So in my numerator, it's going to be negative. My denominator, again, is positive. So that is negative. And so I have concave down. And I think it's pretty simple. I think I can stop on this last one. I don't have an asymptote. All we have there are inflection points. And so if these are inflection points, that means that we are changing concavity, correct? So I can assume without substituting that in this last piece of my number line that we are going to be concave up. All right. So the thing here then is, well, what are the intervals? So let's write the intervals here. So we have concave up. We are concave up. Let's change my colors from that negative 6 square roots of 3 to 0. So we would have negative 6 square roots of 3, 0. Then we're also concave up from a positive 6 square root of 3 to infinity. And then where are we concave down? We are, let's pick a different color. We can do this light blue. We are concave down from negative infinity to that negative 6 square roots of 3. And then we were also concave down from 0 to positive 6 square root of 3. And I think that is all they were asking. Not that we didn't just do a lot. Where is it at? I think that is what they were looking for. So concave up and concave down. And again, there's the function there, graphed, but I'm not interested in doing that. So that's it, guys. It took us a good bit to get through all of that. So if I zoom out, remember I erased some things, but that's a lot of work. So take your time, study, and if you have any questions with anything that I did on this particular video, let me know, and I would be happy to answer your questions.